At a conference in 2013, Quantum Theory Without Observers, you started your talk with this quote from Speakable and Unspeakable in Quantum Mechanics by John Bell. In fact, you've started multiple talks of yours with this same quote, so I'm going to read it out. A final moral concerns terminology. Why did such serious people take so seriously axioms which now seem so arbitrary? I suspect that they were misled by the pernicious misuse of the word measurement in contemporary theory. This word very strongly suggests the ascertaining of some pre-existing property of something, any instrument involved playing a purely passive role. Quantum experiments are just not like that, as we learned especially from Bohr. The results have to be regarded as a joint product of system and apparatus, the complete experimental setup. But the misuse of the word measurement makes it easy to forget this and then to expect that the results of measurement should obey some simple logic in which the apparatus is not mentioned. The resulting difficulties soon show that any such logic is not ordinary logic. It is my impression that the whole vast subject of quantum logic has arisen in this way from the misuse of a word. I'm convinced that the word measurement has now been so abused that the field would be significantly advanced by the banning of its use altogether in favor of the word experiment. So let's talk about the measurement problem in quantum theory. Why is it such a big problem? Why is the entanglement of the observer such a big deal? Why does John Bell propose banning the word measurement altogether?
Well, it's not that measurement is such a big problem. It's that the use of the word measurement is a problem when that word is inappropriate. Mm-hmm. If you think the word, if you misuse a word, you can get yourself confused. That word is misused all the time. That's a source of a great amount, if not most of the confusion in foundations of quantum mechanics. Don't abuse language. This is true in ordinary life, and it's true in spades in mathematics, and it's certainly true in physics as well. Don't abuse language. It's hard enough to think straight when you use language in a careful way. Yeah. If you're going to use language in a careless way, you're going to go off the rails pretty quickly. That was Bell's complaint. And then the proof that Bell was right is all the nonsense that people have said about quantum mechanics. From the abuse of a word, from the misuse of a word. Measurement doesn't really mean measurement. Observable doesn't really mean observable in the usual sense of the word. And yet you speak about a measurement and observables as if they were the familiar kinds of things we have in classical mechanics. It's not like that. It would be very good if quantum mechanics could be taught in such a way that just textbook quantum theory, but in such a way that language isn't constantly being abused.
I guess I'm still not clear on why or how the word measurement is being abused and what problems it's causing in quantum theory. Why is it such a big deal that the word measurement is being used and the observer is such an integral part of quantum theory?
Well, think about the no hidden variable theorems. You get into all kinds of contradictions there. Some physicists have argued that these no hidden variable theorems and the contradictions you get to prove that there's no reality until you look. But they prove no such thing. All they prove is what you were doing were not measurements. You were just doing certain experiments. If in these theorems, you replace the word measurement by the word experiment, you would draw no such conclusions, no striking conclusions, and the contradictions would go away. What the no hidden variable theorems actually show are what are called quantum observables, which in the mathematics of quantum mechanics are associated with what are called certain abstract objects called self-adjoint operators on Hilbert space. And only students of quantum mechanics or mathematics might know what I'm talking about. But there are certain abstract objects. And if they're called the observables. What the no hidden variable theorems show is that there's no decent way to associate these observables with values in a manner which would agree with the predictions of quantum mechanics if in what are called quantum measurement, you were just revealing those values. That's what leads to all the contradictions. That's what leads to the conclusion that measurement must create reality. Well, if measurement were measurement, maybe it would have to be creating reality. Although that itself would be a contradiction, since if it's creating reality, it's not measurement anyway. But if these were not measurements, which were really experiments, there'd be no need to talk about anything creating reality. So the no hidden variable theorems in quantum mechanics, which have had an inimical role, are all based on the misuse of the word measurement. That's one good reason to avoid misusing that word. If you want to understand what's going on in quantum mechanics, you will have a lot of enormous difficulty if you talk about things being measurements when in fact they are not.